Hello, welcome to this topic on greenfield construction of overhead lines, part 6. At the end of this topic, you will be able to explain manual installation and erection of distribution transformers, list the tools and equipment needed to erect a distribution transformer, describe the mounting arrangements for distribution transformers. Let us start with the installation of the structure for distribution transformer. The steps for manual erection of distribution transformer structure and accessories are as follows. Check all structures physically for lifting points. Use lifting arrangements. Secure the structural member with the lifting sling. Ensure that all sharp edges on structural steel supports are removed. Barricade the working area with warning tape and a safety cone. Use tools bag for carrying all tools and tackles like a wrench, spanner, etc. Lift the material at height by means of a PP rope. Lift clamp for anchoring rope pulley and fix the clamp on the pole. Lift the rope pulley and fix on the erected clamp. Lift the support of every piece of equipment first and fix it on the pole. Lift the equipment, lightning arrestor, AB switch, dropout fuse and distribution port and fix the erected support. Check the alignment by spirit level and tight nuts and bolts properly. Remove all the loose materials from the height. The following are the equipments and tools required for the erection of distribution transformer. Pulley block, belt sling, come-along clamp, D-shackle, max puller, crane if it is required. Let us discuss the checkpoints before installation of distribution transformer. The following checks are to be carried out before transportation to the location and again before erection. Transformer bushings are to be inspected for cracks or damages. Oil level in the transformer needs to be inspected. Inspect for any oil leakage at body or drain, valve, bushings, gaskets, welded joints. Measure insulation resistance values on primary side, that is 11 kV, measure with 5000 volt measure between face to earth on HV side. On secondary side, measure with 500 volt measure face to earth on LV side, HV side to LV side for healthiness. Recommended IR value for 11 kV and 6.6 kV side is 200 to 400 megohms. If the value is not in the above range, follow the instructions provided in the operation and maintenance manual. Verify with the factory test reports to assure whether all the routine tests have been conducted or not. The following are the mounting requirement for distribution transformer. In practice, distribution transformers are mounted on single pole, double or H pole or on the plinth. Single phase distribution transformer up to 25 kVA can be mounted on single or two pole mounting. Three phase distribution transformer up to 500 kVA can be mounted on 2 or 4 pole. Three phase distribution transformer greater than 500 kVA are to be mounted on plinth with fence. However, the final call on the arrangement will be taken by the respective DISCOMs. As per Indian standard 1180, three-phase distribution transformers having a capacity greater than 500 kVA are to be mounted on plinth only. The images show mounting arrangements for distribution transformers on single pole mounted, H pole mounted and plinth mounted. Let us discuss how to manually erect distribution transformer using chain pulley blocks. Here are the steps. Check all the structures are erected as per the drawing. Place the distribution transformer near the location of the pole or the plinth. Place the FRP ladder on the pole to climb on the pole. Fix the chain pulley block on the structure with the help of a wire rope sling. Fix the sling on the lifting hook of the transformer and tie the tag line. Lift the transformer and ensure that the bushing of the transformer does not come in contact with any structure. Place the transformer on the transformer resting base channel by means of the tag line. Welding work for GA flat shall be done on the ground. Ensure that the base channel is horizontally leveled. While erecting the transformer, it is to be confirmed that the base channel of the transformer is in line with the conditions laid down by REC specification. When the distribution transformer is lifted from the ground level to the bracket on which it is to be placed, jerk should not be there as it may disturb the internal parts of the transformer. The erection of the transformer can also be done using a crane for easier and safe handling. During transformer installation, the following checks should be performed. The base channel on which the distribution transformer is to be mounted must be in line and level. This is very important. Before placing the transformer onto the structure, cross-check whether the orientation of the transformer is in line with the drawing or requirement. Also, check whether all the other equipment mounted on the structure is in correct location. Usually, dropout fuse or horn gap fuse unit and the HV bushings of the transformer will be on the same side. When we are terminating the cables at the LV side of the transformer, if a cable box is provided in the transformer secondary, we must use double compression gland and suitable lux crimping type. This will avoid loose connection and load on the transformer terminal. If a cable box is not provided, after properly arranging cable clamping, termination may be carried out using lux and crimping. Now let's learn about the transformer earthing. The reference is made to IE rule number 61 of subclass 1 and 61 of subclass 2. According to these rules, distribution transformer's neutral bushing and distribution transformer body both are to be independently earthed through two separate treated earth electrodes. This rule is being complied by providing 3 treated earth pits as per IS 3043 arranged 2 in a pattern to form an equilateral triangle. Earth electrode number 1 is used for connecting the lightning arresters. Earth electrode number 2 is used for connecting the distribution transformer's neutral. Earth electrode number 3 is used for body earthing of the distribution transformer and other equipment structures and body earthing. The 3 earth electrodes are connected to each other and an earth bus is formed at a depth of 300 mm from the natural ground level. Such an earth bus should not have earth resistance greater than 2.5 ohms. Next, let's talk about the checks that must be completed before energizing the line. The following erection checklists are to be referred to and once again checked for the correctness of the installation. Pole erection checklist including root alignment, structure erection checklist, equipment erection checklist, earthing checklist, guy set checklist, stringing checklist, binding jumpering checklist, equipment site acceptance test reports with reference to acceptance criteria, checklist for span-wise clearances both ground and face-to-face, approval obtained from other authorities. Let's summarize what we have learned so far. Explain manual installation and erection of distribution transformers. Listed the tools and equipments needed to erect a distribution transformer. Described the mounting arrangement for distribution transformer and understood the points which are required to be considered before charging a line. So far in the session of green field overhead line installation, we have talked about survey and we have talked about various types of poles, pole erection, stringing, guy set, etc. And we have also seen in the survey that if the survey drawing is 100% correct, from where we will have to go for the bill of quantities so that all the materials what you require to complete a line is available. Now here we will try to have some details about the BOQs, how it is arrived at, and we will also try to understand about the terminologies called the span, the root alignment line, the single pole, double pole, triple pole, 4 pole. Okay. We will try to understand the single poles, the V cross arms, the cleat, the root alignment line, the span, and the angle of deviation, and in that what are all the minor angle of deviation, which are important angle of deviation, at that point which type of pole is to be selected, and how the line is getting tapped off from a particular point for a single circuit, and we will also see how a double circuit line goes and then try to bifurcate at a particular point. To start with, we will try to see the drawing which is being shown on the screen. The red one indicated in the drawing is a simple pole, a single pole, and the longer one indicates the cross arm. For clarity, we have not provided the detail of the top cleat. All these 3 poles which are showing is single pole suspension pole, and maximum span as approved by the existing line authorities is 100 meters, provided it is a straight line. At every 1 kilometer, we are supposed to break the line where we try to introduce one double pole structure as indicated in the isometric view which has been shown, wherein we try to cut the line and then try to provide a jumper to continue the line. There is no need to say that required stays are to be provided as per the requirement. So, the line goes, there is a double pole at 1 kilometer, and then further the line continues. This photograph indicates the line which has been drawn, which is going straight with maximum span, single simple pole and a double pole cut point. Now, next is that we will try to understand what is the angle of deviation. The root alignment line and the position when it takes a turn, the degree which falls with the right root alignment line and the present pole location is called the angle of deviation. In the first pole you can see 5 degrees and in the next pole it is shown as 10 degrees. Now these are all called minor angle of deviation, where you can use the single pole itself. When the angle of deviation is more, then we try to go for a cut point as shown in the figure. After this, we have a single pole cut point wherein it takes a 90 degrees turn. In this place, we try to use two structures which are perpendicular to each other as shown in the drawing, and as shown in the photograph, you have a cut point using a single pole. Next, we will try to see what happens when we try to go for a 90 degrees if there is not a single pole being used. Generally 90 degrees, 3 poles are to be used, and the cut point need to be taken in such a fashion as shown in the isometric view. 3 poles through which the line goes and takes the turn to left at 90 degrees. The isometric view indicates how the structures are being used to brace all the 3 poles. So angle of deviation is greater than 60 degrees. We can use either a 3 pole structure or we can use a 4 pole and corresponding structures. Now let us see how a 4 pole structure is being used for taking tappings on either direction. A single circuit line is drawn, it reaches the 4 pole structures and it tries to take 2 directional lines, one on the left and one on the right. Thus 4 pole structure is being used for taking both the tappings. Now let us see, it is a 33 kV line which I have shown. The 11 kV line also will be done in the same fashion, a double circuit line, but only thing is that the pole height and the insulator used for that is changed. Now it comes and it gets into a 6 pole structure, after which it is trying to take deviations. We will see how the BOQ helps you.